So if we're asked to find the center and major and minor axes and foci, that must mean this thing has to be an ellipse, because only ellipses have major and minor axes and foci and are added together. So it's not a hyperbola, which also have them, but it's a plus, so it has to be an ellipse. So in order to do that, here is my general form. X minus h squared over a squared plus y minus k squared over b squared equals 1. So that's what we're trying to make this equation look like, and we'll do that by completing the square. So I'm going to use up all this information and then probably have to erase it later, but so be it. So we start by getting our x things together. That's not dark enough. So 4x squared minus 8x is our x stuff. We'll get our y stuff together. Y squared plus 6y, and we'll move our non-variable to the other side. So those are the first steps in completing the square. Now we notice that I have a 4 in front of my x squared, which is not exactly the best thing to complete the square with. So I factor a 4 out of both of my x terms, and now I can complete my square. So I'm looking for a number that I can multiply in there. Now the y doesn't have a coefficient, so I can just do that one regular. Y squared plus 6y plus a box. I guess I need to make it bigger. And that equals 23. Of course, we have to add boxes to both sides in order to keep this thing algebraically balanced. So a gray box from here and a pink box from there. So we need to calculate what number goes in our box, and that's always half of this number squared. So half of 2, negative 2 is negative 1, negative 1 squared is 1. But in order to come over here, I have to multiply that by my outside common factor. So 4 times 1, we get a 4 in this box over here. And half of 6 is 3. 6 squared is 9. So that just goes in here because I have no common multiplier. So now that I have a perfect squared trinomial, I can factor this, and this factors to, sorry, not y, but x minus 1. X minus 1 squared. These 3 now factor to y plus 3 squared. And this equals 23, and 13 is 36. Okay, now in order for it to equal 1 on the right side, I'm going to divide everything by 36. Okay, rather than subtracting 35 from everything, I'm going to divide, I just wrote 35, by 36. Okay, so that gives me the 1 that I'm looking for, equals 1. And now the rest of it I have to do a little simplifying. So 4 and 36 can reduce to something over 9. X minus 1 squared over 9. And this is just going to be y plus 3 squared over 36. So there is my general equation, or rather my standard form of an equation that will graph to be an ellipse. Let me erase all this wonderful algebra here. You can always rewind if you want to see it again. So let's go ahead and put our center on here. Our center comes from, here is a positive 1 in the x and a negative 3 in the y. So 1 right and 3 down. That's where the center of our ellipse is going to be. And we're going to go the square root of 9, which is 3 units in the x direction. And we're going to go the square root of 36 in the y direction. So this ellipse is going to be taller than it is wide. 1, 2, 3, 4, 5 off the graph. And do your best to make it look as elliptical as possible. Whoops, missed it. Anyway, not my worst one. Probably not my best, but so be it. And the last thing you want to do is plot your foci, your two focuses. And the foci is found by square rooting 36 minus 9. So we always look at your denominators, the larger one minus the smaller one. Or if you want to do it, you can take the absolute value of the difference. It doesn't really matter. So 36 minus 9 is 27. 27 is about 5.2. So back from your center, you count 5.2 units along your major axis, and that is where your foci will go. So this one is at the point 1 comma about 2.2. And this one is at the point 1 comma negative 1, 2, 3, 4, 5, 6, 7, 8, 8.2. So those would be the points that go with your foci for this ellipse.